So we were able to see an actual cultural preference just looking at things like color. So it was an interesting example of being able to do cultural anthropology just from your office chair using the web as a research tool rather than going out.
So you may want to see how you want to color your IBM sales site in China.
Exactly so. And in fact, we talked to some fashion designers who shared with us the fact that they've known forever, which is if you look at freshmen in Germany and their color preferences, those are the colors that will be popular the next year in Paris. They are the absolute most leading exemplar that they have. After Germans have served their one-year military service, they go to college. That year, they seem to be the leaders for what colors and cuts of fabric will be popular in the next year. So, the things you learn. So to conclude, secondary use is where the action is. People have, collecting data for a purpose, analyzing data for that purpose, and getting a result has been beaten to death. People have done it all over. Collecting data for one purpose and doing something entirely different with it is a new domain where there's a lot of interest in things going on. It requires an understanding of text analytics and at least a cocktail party understanding of the target domain. You need to at least have enough understanding to make sense of what an expert in that domain is telling you. Incorrect and informal language is the rule, not the exception. If you take the nice Stanford parser and you run it on it, it's not going to do terribly well. Context is critical. Figuring out information, especially in these domains, is not self-contained the way it is in a Trek document. It's scattered. You've got to know who the poster is, what they've posted in the past. And you have to have a solid theoretical grounding in the analytics and what you're going to do. But you also need a practical engineering know-how to know when to ignore the theory, hack a heuristic, and move on. So it's a difficult tension to keep, but it's critical in getting this to work. Any questions? Really, we should have had coffee.
So do you primarily just use statistical analysis to come up with most of these results, or do you...
So the most typical way we work is we use statistics to generate candidates. Mm-hmm. So we take, let's say, 800 million cardiology records. We use statistics to generate 500,000 that look interesting. We feed those 500,000 into a natural language processing system. If we fed all 800 million in, we'd be there until the end of the world waiting for it to process. So we generate candidates by statistics and then vet the candidates by other methods. Yes?
I think you mentioned earlier that 90% of the web is metadata.
No, 90% of the systems that we build are metadata.
Okay, I see. Okay.
And that's because the metadata helps you leverage the data in different ways.
But I think interestingly, if you look at take a search engine, such as Google or Bing or something, they obviously make a copy of the web, right? Mm-hmm. And they generate metadata, they generate index.
Yeah, 50%.
In that sense, yeah,
they're at 50%.
That sense that is there, and I think that is only increasing in a way. Mm-hmm. In that much of the web, with Web 1.0, what we say, you focus on getting a page, but more and more you see it is more about association, and so you have I think natural tendency to having to figure out metadata with regular associations of how one thing relates to another, rather than just that one thing. So I think we keep on increasing metadata. Plus, increasingly we are going to get better at non-textual thing. Yeah. And there is a totally different, I think, dimension of indexing there. So, or metadata in there.
Yeah, in specialized images like echocardiograms now, we have computer vision that's tracking movement of heart walls and finding diseases that the human eye can't spot, but which a computer can see, hey, that piece of the heart wall isn't moving quite right. Mm-hmm. Maybe you want to take another look at it. Mm-hmm. So that, and as that happens, more and more we're generating enormous amounts of metadata around that. Yes?
You mentioned earlier about work where you're trying to identify if two or different entities are same or not based on the characteristics.
Yes.
Have you guys tried to apply that for the semantic web where URIs are basically the identifiers and they can have multiple attributes encoded in multiple formats? We
haven't done it in semantic web. It would be challenging because you need two corpora that heavily overlapped, and generally people pick a URI schema to use. They don't use two different URI schemas, which you need to do that. But you could certainly, it'd be worth trying, especially if the schemas were, phrase, link, another phrase, and then see where those targets are. It'd be one way to do it. It'd be a lot like effortful translation if you're familiar with that work. Yes?
In the same alias detection problem, in that case only, is the writing pattern only the way that you see in order to differentiate or distinguish it's the same person who's writing again?
Yeah, so there's been a lot of work done on this in the gaming domain, especially gaming discussion sites. I won't mention which company, but they have a problem with people who are posting inappropriate information on their site, basically using profanity or whatnot, and they want to block that person. So you look at IP address, you look at language use, you look at a whole bunch of different characteristics. Interestingly, they found out that if you ban someone from the site, they will just create something and come right back.
Mm-hmm.
The single most effective thing to do was to modify their code so they were the only ones who saw what they posted. And fairly shortly they'd get more and more, trying to get a reaction out of people, and people just ignored them, and then they just disappeared. And that worked much better than kicking them off. But yeah, social engineering on top of. Any other questions? Yes?
Can you comment from your experience on what are the characteristics that are different, what are the techniques that worked and did not work between things you've done on the internet using the web data and intranet?
Yeah, great question. How many people here have a link to their favorite admission site at Wright State? No one. How many people have a link to your favorite bursar site at Wright State? No one. Link-based popularity graph mining like PageRank doesn't work terribly well inside the enterprise. People really don't socially link to things inside the intranet the way they do in the web as a whole. So all of this graph-based analysis that's been so successful in the web as a whole fails utterly on the intranet. So you much more have to look at other clues. You have to parse the text, you have to pull out entities, you have to say everything on this site looks like an HR document, we're going to guess it's an HR site. Everything on this site looks like a bursar's site, right? And of course you're going to get that wrong a fair amount. So one thing that's been very popular inside IBM has been social tagging, which people will do inside the enterprise. After you finally track down the darn HR site, you can put a tag on it. And that has been successful inside the enterprise in a way that linked structure analysis has not.
What about characteristics of text?
So inside the enterprise, so this is work, actually Julia Grace did some good work on this. If you write something to someone who you write at the 3rd to 5th grade level. If you write to someone you don't know or know only in a professional context, you write in roughly the 6th to 8th grade level. So you can actually do a frightening amount of analysis just with an automated reading index as to what the relationship is between the two people who are exchanging emails. Or whether this is a site about a company picnic versus a new rule about how we're going to handle something in finance. So that the best sort of indicator there we found is the formality of the text, giving you some sense about what's going on top of the standard ontologies of what's being talked about. Duplicate detection is also big, and versioning is also big. Here are 2 versions of the same PowerPoint. Which one came first? Those sorts of questions. Yes?
I was wondering if you could comment on the ways that you have used domain models and particular cases where they were particularly useful or types of uses you've seen for.
Yeah. So Mina did a paper with us that we found was very useful. So if I have a mention of an artist in a discussion forum, and it's ambiguous, it could either be the name of a country music group or a pop group. And the other people mentioned in the forum are the Rolling Stones, the Beatles, the Clash, right. You can guess which group, this ambiguous entity probably should resolve to one that has similar characteristics to other entities that are in this forum. And that worked remarkably well. So we used music brains as the ontology to find genres and identify artists clusters that similar artists are talked about in similar locations. So that was an example where it worked really, really well. Other cases.